All right, 3.4. So let's talk about enzymes. And so enzymes are just those macromolecules that catalyze or speed up reactions. And they do this by lowering the activation energy. The energy it requires a reaction or a spontaneous reaction to go from a reactant to a product. Okay, the enzyme itself, when placed into this reaction, is not being consumed. Okay, nothing is happening to the enzyme itself. It is just helping the reaction to occur more quickly. And so enzymes are just proteins. Remember, a chain of a polypeptide of amino acids. And anytime you see the suffix, not suffix, it's not a prefix either. Anyways, ignore me. When names of molecules are ends in ASE or ACE, they are an enzyme. And so a good example that I use and that we'll do when we get back to school is lactase. And so if you're lactose intolerant, that means that you lack lactase in order to break down the protein within milk. And so it actually says right there on the box that it is a lactase enzyme supplement. Wow. There's a bunch of different ones, but as long as it ends in ASE, it is an ACE or a enzyme, a protein. And so the basic structure of an enzyme is a protein substance, right? But it's going to have a couple locations for different substrates or molecules to bind to. Oops. And so these sites or these locations are known as active sites. Okay, so this round one right here is what it's referring to as an active site, an area for something to bind to. And so in order for enzymes to function, they need to bind to substrates to catalyze those reactions. Without the substrate, the enzyme does not function. Okay. And so while these substrates are within the enzyme, it's held by a weak bond or a weak interaction in the active sites. It does not stay there forever. And remember, this enzyme itself does not break down, this complex. And so when this active site is open, substrates can bind to it, and then this enzyme substrate complex can catalyze those reactions. Okay, those substrates get converted into products. And then once they are released, they can do more work. And so enzymes are kind of like the lock, and they need keys in order to open them. And so there are different types of keys in enzymes, and we're going to talk about them right now. So an induced fit just means that enzymes will change their shape to allow the active site to allow the substrate to bind better, meaning that it will allow a substrate, a square substrate, to come in, but it's going to change its shape to lock it in place or induce the fit. Okay, enzyme catabolism. Okay, the enzyme's going to break down those molecules that bind to it. And so here we see a sideways house looking substrate. It's going to bind to our enzyme, but the product is just breaking apart the house into a triangle and a rectangle. Okay, and so this is enzyme catabolism. And so the opposite of that is enzyme anabolism. And so where two substrates bind to the enzyme in the open site or active site, it increases the chance of this reaction occurring and going from reactants to products. Our product ends up being one piece in the end, and it's building a complex molecule. All right, that's it for 3-4.